Imagine you're at the rooftop of a large building and throw down an iron or wooden ball. What is the eventual velocity the ball will reach? This was the question you had to solve. I've drawn here a ball and some forces are working on it. You have the gravity force, you have the drag force. I also have given you some numbers about that were given in the text. You have to calculate the area perpendicular to the velocity, and this is just a circle, which is pr squared, and if you rewrite this, you will get 7.85 times 10 to the minus third square meters. If you cannot get it so quick, please just stop the video. Then you have to set up a force balance to calculate the velocity the ball will reach. This will mean that all the forces working upwards are equal to all the forces working downwards. So the buoyancy force plus the drag force is equal to the gravity force. Well, the force B is for buoyancy, D stands for drag force, and of course the G stands for gravity force. If we rewrite the force balance to the drag force, we will get Fd is Fg minus the buoyancy force. Now we set in the text that the buoyancy force was negligible compared to the other forces. This is because the density of the iron ball is so large that the buoyancy force has almost no influence. So we can rule the buoyancy force out. We also have given some equations for the drag force and the gravity force in the lectures. So the drag force is equal to a drag coefficient times the area perpendicular to the velocity, which is downwards, times half times the density of air times the velocity. And the coefficient of drag force is dependent on Reynolds, as you can see in this graph. It is a graph that correlates the Reynolds number for a sphere to the drag force coefficient. The red line is the one you can use. Blue line is actually the Stokes law. Then for the gravity force is m times a. It's also rho times the volume times a. And a is the acceleration, which we can write as g as well. The drag force is equal to the gravity force. Since we neglected the buoyancy force, we write equations out. You can get this equation. If we rewrite this for the velocity, we get this equation, and then we take the root. And of course, still the drag force coefficient depends on the Reynolds number. And for the Reynolds number, we also know an equation, which is the density, in this case air, times the velocity of the sphere times the diameter of the sphere, divided by viscosity. Then we have to use the iteration process, and I will show you how this works. First we take a guess. In this case we take 10 meters per second. We're using an iron ball, so I think this might be on the low side, but let's see. Then we can calculate the Reynolds number, which is the density of air times the velocity, which is 10 meters per second times diameter divided by viscosity. If we fill in the numbers, we will get 1183 and no units. Now we have to go look into the graph. We search for the Reynolds number of 1000. Watch out, since this is a log scale, and then we can read out the drag coefficient. In this case, the drag coefficient is 0.43. We can fill this in our equation for the velocity. Let's fill this in. Rewrite the equation again. In this case, the acceleration is just the normal acceleration on Earth, which is g. So let's fill in the rest of the equation. If we fill in the numbers, we know them all. Since we are doing this for iron, we fill in the density for iron, which is 7,800 kilograms per square meters. The only difference for the wooden ball is the density, so you should fill in 800 kilograms per square meters if you do this for wood. For iron, we get a velocity of 61.5 meter per second. Now this is an iteration process. This means we continue doing the same process until we reach the same velocity twice. So now with this new velocity I can also recalculate the Reynolds number, which is higher. I can look into the graph and find a drag coefficient of 0.41. I have a new velocity, work out a new Reynolds number, again drag force coefficient, and again I can calculate the velocity. 2 times I have now 60.0 meter per second, so this is 2 times the same for iron, and this is the number we are looking for. You can do the same for wood, you will find a different number. Thank you for watching and good luck with the rest of the exercises.